All right, the last type of graphs, again, it's a sine and a cosine that are by themselves, except it's the sine of 2 theta and the cosine of 3 theta, okay? So plain old sine of theta, cosine theta, circles. Sine of 2 theta, 3 theta, 4 theta, cosine of 2 theta, 3 theta, 4 theta. These are going to be your roses. If it has an odd number for your argument, this is going to have that exactly that many petals, so this one will have 3 petals. If it has an even number, it's going to have twice as many petals. So 3 theta, 3 petals. Again, if you're good with symmetry, once you get the gist of one, you can usually go through and kind of pop through the other ones. I'm again going to go through the table. Because if you're not good with the symmetry stuff, or if something looks off, these are very symmetrical graphs, and so you can see if you did something wrong. And so this is what you're always going to fall back on, is going through the table and plotting those points. So 0, 4. Pi 12ths, 2.8. Here's another. This is going to be pi 6ths, 0. Pi 4ths and a negative 2.8. Negative 4. Again, another negative 2.8. And then at pi halves, back to 0 again. Here again, we're at 2.8, 4, 2.8, 0. I've got every petal. Now these are not jagged lines. These are petals. Petals of a pretty flower, round petals. And again, these are not going to cross. They're going to stay in between those lines as you're doing this. So 3 theta, 3 petals. Sine of 2 theta, I'm going to have 4 petals. This is a 4. The length of my petals is 4. This is a 4. The length of my petals is going to be a 4. Zero, 0. Pi 12ths, 2. 3.4. 2, 0. Oh shoot, I missed one. 3.4, 4, 3.4, 2, and 0. I knew that wasn't right because these are always going to be, if that's an even number, they're always going to be all symmetrical and perfect. And so in the case when you have 4 petals, if it's a sine graph, they're always going to be right, the tip is always going to be right at pi 4ths and 3 pi 4ths and 5 pi 4ths and 7 pi 4ths. So this is a great situation where you could repeat that pattern in these other quadrants. This particular one here then goes to a negative 2, negative 3.4, negative 4, and then again 3.4 and 2. Pi, we're back to 0, so now we're down here at 2, 3.4, 4, 3.4, and 2. And then it's in this last quadrant that actually we get the negative values again. So we're at a -2, a -3.4, negative 3.4, -4, -3.4, -2. Nice, rounded, and I'll give you an example here in a second of what I see and why I keep pointing out the whole rounded thing, because this is not a kindergarten connect the dot lesson. This is a highly complex graphing of polar forms. But what I often see on a graph like this is I will see a little sword. Somebody will go like this, like this, like this, and I'll have these nice little spiky petals on here. No spiky petals. This, we want nice, rounded, where they don't cross where they shouldn't. That's what we're looking for on these graphs.